everyone, this is your Kalpana here. So in this video we are going to evaluate two integrals. Okay, so let's get started. First one, integral cos x minus cos 2x by 1 minus cos x into dx. Okay, so here we are having cos 2x. We know that cos 2x is equals to 2 cos square x minus 1 or equals to 1 minus 2 sin square x. Okay, so let us consider cos 2x equals to 2 cos square x minus 1. Okay, so this equals to integral cos x minus, you can replace cos 2x by 2 cos square x minus 1 by 1 minus cos x into dx. So this equals to integral cos x minus 2 cos square x minus into minus plus 1 by 1 minus cos x into dx. Okay, so here in order to reduce the complexity of the problem, we are going to cancel the denominator 1 minus cos x, okay, by making some changes in the numerator or in the numerator and denominator. Okay, so here you are having cos x minus 2 cos square x plus 1 by 1 minus cos x, right? So I could write it as minus 2 cos square x plus cos x plus 1. This is cos, not cot, okay? By 1 minus cos x into dx. Okay. So here we can take minus common from the numerator and the denominator, or you can multiply the numerator with minus and the denominator with minus. Instead of taking common, simply you can multiply numerator with minus and denominator with minus. See, I'll show you. So if I'll take minus common, I'll get minus of cos square x minus cos x minus 1 by minus of cos x minus 1 into dx, or now we are going to multiply with minus in the numerator and in the denominator. So I'm going to multiply with minus, right? So minus into, I'll write simply minus into minus, minus into minus 2 cos square x plus cos x plus 1 by minus into 1 minus cos x into dx. Okay, so previously we have taken minus common, right? So now look at this. If you will multiply with minus, minus into minus plus 2 cos square x, again minus into plus minus cos x, again minus into plus minus 1, and in the denominator minus into 1 minus 1 minus into minus plus cos x. Okay, you can use any of these two methods. Either you can take minus from the numerator and denominator, or you can multiply with minus in the numerator and in the denominator. Okay, it's up to you. So now this is equals to integral 2 cos square x minus cos x minus 1 by cos x minus 1 into dx. Okay, so here our main motto is to cancel the denominator cos x minus 1. So for that purpose, what we are going to do is, you are going to change the numerator. So minus cos x, we are having minus cos x. We know that minus 2 cos x plus cos x will be minus cos x, right? 2 minus 1, minus 2 plus 1 is minus 1 into cos x, right? So you could write minus cos x as minus 2 cos x plus cos x minus 1 by cos x minus 1 into dx. Okay. Why we are writing this? Because we need to cancel the denominator. If you change this minus cos x to minus 2 cos x plus cos x, we can write the numerator in terms of cos x minus 1 by taking common. Okay. So this equals to integral. See here you're having cos square x and cos x, you're having 2 also. So you can take 2 cos x common. If you'll take 2 cos x common from these two terms, you'll get cos x minus 1. 2 cos x into cos x is cos square x minus 2 cos x into 1 is 2 cos x plus cos x minus 1 by cos x minus 1 into dx, right? So now take cos x minus 1 from these two terms. So you'll get cos x minus 1 into 2 cos x plus 1 by cos x minus 1 into dx. So now you can cancel cos x minus 1, cos x minus 1. And finally you'll get integral 2 cos x plus 1 into dx. So by cancelling the denominator and one part in the numerator, we have reduced the complexity of the problem. So now we can solve this easily, right? So you could write it as integral 2 cos x dx plus integral 1 into dx. So now you can take the constants outside the integral. You'll get 2 into integral cos x dx plus integral dx. Since we know that integral cos x dx equals to sin x plus integral constant c and integral dx equals to x plus integral constant c. So now we are going to apply this formula. You'll get 2 sin x plus integral cos x is sin x plus integral dx is x plus integral constant c. Instead of writing integral constant for each integral, we can write simply one constant at last. Okay. So therefore, this is equals to 2 sin x plus x plus c. So therefore, integral cos x minus cos 2x by 1 minus cos x into dx is equals to 2 sin x plus c. Okay. So here we have used the first formula, that is 2 cos square x minus 1. Now let us see what happens if we use 1 minus 2 sin square x. Solution. So now we are going to use cos 2x equals to 1 minus 2 sin square x. Okay. So we are having integral cos x minus cos 2x. So you can replace cos 2x by 1 minus 2 sine square x by 1 minus cos x into dx, which is equals to integral cos x minus into 1 minus 1 minus into minus plus 2 sine square x by 1 minus cos x into dx. Since we know that sine square x plus cos square x equals to 1, now we can replace this 1 by sine square x plus cos square x. So you'll get 1 into minus into or minus of sine square x plus cos square x plus 2 sine square x by 1 minus cos x into dx. Okay. So we could write it as integral cos x minus into plus minus sine square x minus into plus minus cos square x plus 2 sine square x by 1 minus cos x into dx. Okay. So now we are having minus sine square x and plus 2 sine square x in the denominator, right? In the numerator, sorry. So from this you'll get cos x 2 sine square x minus sine square x is sine square x. So you'll get plus sine square x minus cos square x by 1 minus cos x into dx. Okay. So now, in order to reduce the complexity of the problem, we are going to cancel this denominator. To cancel this denominator 1 minus cos x, we have to change the numerator in terms of 1 minus cos x. That is, we are going to change the numerator in terms of cos x. But we are having sine square x. So how we can change this sine square x? Since you know that sine square x plus cos square x equals to 1, right? Now take this cos square x to right hand side, you'll get sine square x equals to 1 minus cos square x. Now replace this sine square x with 1 minus cos square x, you'll get integral cos x plus 1 minus cos square x minus cos square x by 1 minus cos x into dx. Simply we are replacing sine square x by 1 minus cos square x. So this is equals to, I'll remove the brackets, okay? Fine. So you're having cos x plus 1 minus cos square x minus cos square x. Okay. I could write it as cos x minus cos square x plus 1 minus cos square x by 1 minus cos x into dx. Why? Because I want to take cos x common from these two terms, these two, or you can say these two. Okay? Fine. So this is equals to integral. Now I'm going to take cos x common from these two terms, the first two terms, right? From the first two terms we are taking cos x common, then we'll get 1 cos x into or cos x of 1 minus cos x plus. We are having 1 minus cos square x. You could write it as 1 square minus cos square x, which is of the form a square minus b square. You could write it as a plus b into a minus b. So now I'll write it as 1 plus cos x into 1 minus cos x, right? By 1 minus cos x into dx, right? So now in these two terms we are having a common term 1 minus cos x. So you can take this common, right? You'll get 1 minus cos x into cos x plus 1 plus cos x by 1 minus cos x into dx. Now simply you can cancel 1 minus cos x from the numerator and the denominator. So now the complexity of the problem is reduced. So this is equals to integral cos x plus cos x 2 cos x plus 1 to dx. So we can write it as integral 2 cos x dx plus integral 1 into dx. Since we know that integral cos x dx equals to sin x plus constant, integral constant. Integral dx equals to x plus constant. Okay. So you'll get, okay. Now take the constants outside the integral. You get integral 2 into integral cos x dx plus integral dx. 1 into dx is dx, or you can say 1 into integral dx, right? So finally you'll get 2 into, we have integral cos x equals to sin x, so replace it, plus integral x is integral dx, sorry, x plus totally and integral constant. Okay, same. Okay, we got the same answer while using cos x equals to 2 cos square x minus 1. Okay, so you can use any of these two formulas. So therefore integral cos x minus cos 2x by 1 minus cos x is equals to 2 sin x plus x plus c. Okay. So now coming to the second problem. Evaluate integral 3 sin x minus 2 cos x plus 4 secant square x minus 5 cosecant square x into dx. So you would write it as integral 3 sin x dx minus integral 2 cos x dx plus integral 4 secant square x dx minus integral 5 cosecant square x dx. Okay. So now take the constants outside the integral. 3 into integral sin x dx minus 2 into integral cos x dx plus 4 into integral secant square x dx minus 5 into integral cosecant square x dx. Okay, since we know that integral sin x dx equals to minus cos x plus integral constant, and integral cos x dx equals to sin x plus integral constant, and integral secant square x dx equals to tan x plus integral constant, and integral cosecant square x dx equals to minus cot x plus integral constant. So now we can use all these formulas here. So this is equals to 3 into integral sin x is minus cos x minus 2 into integral cos x is sin x plus 4 into integral secant square is tan minus 5 into integral cosecant square x is minus cot x plus integral constant c. So this equals to minus 3 cos x minus 2 sin x plus 4 tan x minus into minus plus 5 cot x plus c. Okay, so therefore integral 3 sin x minus 2 cos x plus 4 secant square x minus 5 cosecant square x into dx is minus 3 cos x minus 2 sin x plus 4 tan x plus 5 cot x plus c. So this completes the problem. Fine. So we have seen two integrals in this video. Hope you will understand. We'll see you in the next video. Until then, bye bye.